In this video, we're going to talk about how to calculate work. And real quick, I just want to write down the formula. Work equals force times distance. Now for our units for these, work is going to be measured in joules, okay? And it's abbreviated. The work symbol in the formula is abbreviated capital W, force is F, and then D is distance. For our units, work is going to be measured in joules. Joules is going to be the unit of measurement for any type of energy, and work is included for that. And joules is abbreviated with a capital J. Now for force, force is measured in newtons, and that's going to be a capital N. And then distance is going to be measured in meters. And of course, this D goes with distance. And meters is going to be a lowercase m. So let's jump into solving these problems real quick. How much work is done when a force of 27 newtons pulls a wagon 9 meters? So we have our formula. In the top right corner, work equals force times distance. So let's list out those variables. It's asking how much work is being done. We have a force of 27 newtons and a distance of 9 meters. So all of those are in the appropriate units to use this formula. Work equals force times distance. That's going to be 27 newtons times 9 meters. Plug that number in our calculator, and we get 243 Newton meters. Now the thing that you need to know about joules, so 1 joule actually equals 1 Newton meter. So when we have a Newton meter, we can just simplify these units and simply say 243 joules. Misty does 8 joules of work to push her cart 3.6 meters. How much force did she use? Let's go ahead and list out our variables. It says how much force did she use. So here we're solving for force. We're given a value of 8 joules for the work, and we're given a distance of 3.6 meters. Of course, joules and meters are appropriate distance. Now we just need to rearrange this formula and solve for force. So to do that, we're going to divide both sides by distance. Now force is on a side by itself. So force equals work divided by distance. Now we just need to plug in our values. So 8 joules divided by 3.6 meters. Put this in our calculator, and we get 2.2. Equals 2.2 joules divided by meter. Now let's think about how this actually is. Remember that 1 joule equals a Newton times a meter. So if we substitute this in for our value of joules up top, we have 2.2 Newton times meter divided by meters. Here our meters cancel out, and we're left with 2.2 newtons. And remember, Newton is going to be our unit for force. So we want to make sure we simplify that and put it as a Newton. For our last problem, it says Brock uses a force of 32 newtons to lift his grocery bags while doing 27 joules of work. How far did he lift? It should say his groceries, not her groceries, but that's fine. How far did he lift his groceries? So line up the variables. How far? That's asking us distance, so that gets the question mark. We have a force of 32 newtons, and he's done work that equates to 27 joules. So here work equals force times distance. We're going to do something very similar to our previous problem, except now we're going to rearrange and solve for distance. So here we're going to divide both sides by force. That's going to give us distance equals work divided by force. Everything's in the appropriate unit, so now we just need to solve for distance. So 27.0 joules divided by 32 newtons. This gives us a value of 0.8 meters. And again, how do I know it's meters? Remember, 1 joule equals 1 newton times a meter. So currently, if you wanted to write it out as 0.8 joules over newtons, that's the same as 0.8 Newton meter divided by newtons. Well, newtons cancels out, and it leaves you with 0.8 meters.